My dear friends, welcome back to Be Spice. This is Bala with you. In this session, we'll talk about the control valve design specification, wherein we'll focus more on the valve trim, the design, application, usage, the types, all sort of things we will see. Okay. So hope you had watched my previous session on the same control valve design specification, wherein we focus more on what do you call the types of valves like lobe valve, butterfly valve, its application, an angle type valve, and also the rotary type, high performance control valve, and also, the what do you call the features, all those. So basically, the valve types and application we have covered extensively in that first video. So you can spare some time and get benefited, friends. So in this focus is more of a valve trim actually. Okay, we are actually focusing very sequentially so that it is easy to follow. So before going into the details, wanted to inform BSpice has already started the online training on instrumentation design and detail engineering. As part of that, in fact, I started for overseas candidate. In fact, the timing all I just customized based on their requirement. And if you're interested, you can approach me, friends. You can write to me, bspice for you at gmail.com. In fact, I already received 4 5 inquiries from India candidates. I'm planning to conduct the resume the training for Indian candidates very soon. Yeah, it's up to you. If you're interested, you can approach me, right? So once again, thanks a lot, friends, for your support, and special thanks for those who actually become a member, and yeah, now they are actually getting useful info from us, and they are getting benefited, and they are also writing to me. And some of you has not wrote anything to me. You can write to me, and yeah, you can any queries. I'm always there to support you. So that's the point. So with that good note, I'll go directly into the subject. Okay, friends. See, what is trim, friends? Trim refers to all internal process vetted components. Very simple, right? Okay. So to be very precise, trim in control valve includes the valve plug, okay, valve plug stem, the gauge, and the seat ring. As simple as that. So this is the trim, friends. Okay. Now we'll go into the trim design. Okay. So this is the look and feel of the gauge type. It's a gauge type. Okay. And this is a cross-sectional view. Okay. Trim styles may be solid or gauge type. Okay. This is the gauge type. Okay. Gauge, not gauge. Okay. So what is this gauge? Gauge guided, See, basically a gauge guided, what is a type of control valve design that incorporates a cage-like structure. So that is what here, a cage-like structure. What for? To guide the movement of the valve plug and disc. As simple as that. Okay. How it works, friends, actually. See, in the gauge-guided valve, the piston-shaped plug resides inside the surrounding gauge, right? So as the plug moves up and down, it uncovers more or less of the port area in the surrounding gauge, actually. Okay. The gauge also serves as a, to guide the plug, ensuring precise alignment. Oh, that is the point. Okay. So what are all the advantages? See, basically, friends, this gauge, gauge provides stability and support to the moving part, reducing the risk of vibration or, like a flutter during the operation. So that is a one point. And also, is the modification. Modification in the sense the flowing characteristics of the valve can be easily altered by replacing the gauge uh, with another having a different size or shape of holes. So that's the advantage actually. And also maintenance point of view, replacing the gauge is simpler than replacing the plug in other design. Okay. And of course, we have this, balanced plug. Cage guided valves can have a balanced plug which equalizes the fluid pressure on both sides of the plug, minimizing the forces acting on the actuator. So those are the advantages and application point of view. Yeah, it various application like pressure regulator, suction controller, recirculation valve, all these actually. Okay. So that's about the design. Okay, coming back to this subject. Okay, cage type trim shall be avoided on surfaces with solids presence and high viscous. So that is the disadvantage actually. If it is a solid or high viscous, it will get clogged here. So that is the point, friends. Okay, then one more point I want to discuss here. See, for throttling application, with the unbalanced trim, what is unbalanced trim? Okay, I'm going to show you the valve in the the schematic in the next what do you call the slide, but just want to be precise. Unbalanced means very simple, friends. There is no balance hole on the plug. That's it. Okay. So that is the point actually. Unbalanced. Okay. So what is happening here? Yeah, maybe I can talk in the next slide. Okay. Okay. So coming back to this, for throttling application with unbalanced, which has a hole actually. Okay. Unbalanced means what? There is no hole. There is no hole. Okay. So the direction should be flow tending to open. So what is this flow tending to open? So it is nothing but, when the fluid passes through and faces the plug here, okay, it gives a opening act to the plug. It gives an opening act to the plug. So this is called flow to open type of application. Okay, flow direction. So that is the point. So for throttling application with unbalanced trim, the direction should be flow tending to open in order to avoid very unstable forces in a virtually closed position. So that is the point actually. Again, I repeat, friends, for throttling application with unbalanced trim, meaning there is no hole. Okay, the direction should be flow tending to open, meaning when the fluid flow passes through and faces the plug directly, it gives an opening act to the plug. So this is called flow tend to open. So what for? In order to avoid a very large unstable forces in virtually closed position. This is in the unbalanced trim. Just remember, friends. Okay, good to go. And one more point, depending on the application, okay, the TSO requirement, what is that? The tight shut-off requirement will apply for the forward direction or reverse direction or both the direction. Of course, this one we can, consult our process colleagues. Okay, that's the point. Okay, the leakage class, the TSO shall be specified in the data sheet. In fact, we are going to have an exclusive session on this leakage class. That one we will take it up separately because it's a very big subject. I want to take it up separately. Okay. So cage guided valve or balanced type valve shall not be used for fluid that contains solid particles. So that is also another point. Okay. Cage guided, this kind of thing, or balanced type. Again, I will explain that in the next time. Balanced type means there will be a hole actually. Okay. There will be a hole. Right, friends? Okay. How and all I'll explain. Okay. So here the point is that the balanced type valve or gauge guided valve, okay, shall not be used for fluids that contain solid particles. So that is the point, okay? Because, again, you do not get clogged here, the gauge guided, okay? And balance also, you have a holes also, right? So that is also another challenge actually. I will talk more on this next slide, okay? Now, coming back here, this is what I was telling you. Balanced type trimmer shall be used only in clean surfaces. You know why? Because it already has a hole in high differential pressure application above 15 bar. Okay, you see here, friends, this is the unbalanced, right? Here there is no thing. Only the problem is the opening is here. What? The plug and the valve seat, right? That is the only leakage path. But here you see here, this is the balanced type. You have a pressure balancing chamber. This pressure path allows the medium pass through the balancing chamber. Here you can see the pressure balancing force. This is basically the holes, you can see this is how the design actually. Okay. Now coming back to that, the what do you call the definition and the benefit. Okay. So unbalanced, here this is the unbalanced. There is no hole actually. No balance, right? No hole in the plug. This is the unbalance. Okay. So what is this unbalance here? In unbalance, there is no balance hole on the plug. Other point is the pressure differential here. The pressure differential, the medium pressure differential acts directly on the effective okay, effective area of the plug, okay. So here the shut-off capability, it has a better shut-off because there is no hole, so the unbalanced trim has a better shut-off capability because there is only one leakage path. What is the leakage path? This is the one plug and the seat, okay. So that is why it has a very better shut-off capability. So if it is for a shut-off requirement, we have to go for this unbalanced. You got it, friends? Good. Now, suitability. These valves are suitable for application where pressure difference is not large. That is the point. Okay, another point. So it may not handle high pressure difference effectively. So that is about the unbalanced trim. Okay. Now coming back to this balanced trim. Okay. See, balance trim incorporate a balance hole. As I said, right, you can see here the pressure balancing chamber and you have the pressure pot, all these there, and you have the pressure balancing force acting on it here, right? Okay. So this incorporates a balance hole on the valve plug. Okay. Pressure distribution, how it actually, the balance hole allows the pressure to act on both sides of the plug. Okay. That is the another advantage. Then the static force, this the designer, because of this balanced design, it balances the static forces acting on the plug. So that is also another beauty. Then another suitability point of view, the balanced trim valves are suitable for application with a large differential pressure, whereas here it is not, right? Here it is used for large pressure differentials. Okay. So what is the benefit? See, reduced unbalanced force allows the use of smaller actuator. So that is very important. In a balanced trim, balanced type of design like this, reduced unbalanced force, allowing a smaller actuator. But in this unbalanced, you will have a bigger actuator. So always remember, friends, because this I am just trying to, give you the notes as much as possible. Okay. And also this balanced actually give actually improved what do you call improved performance in demanding application, severe application. And also this interchangeable trim options for various flow characteristics, noise attenuation, anti-cavitation features, all are actually available in this balanced type. Only thing is we cannot go for a what do you call the tight shut-off. That is the thing. Otherwise, everything is fine. Okay, friends. I hope you got it right. So to sum up, friends, okay, balanced trim. This one, this one. Balanced trim actually offers better performance in demanding scenarios, while unbalanced trim are simpler but may not handle large pressure difference effectively. That is the difference. Okay. Right. But again, when it comes to tight shut-off, this is the best. Okay. I mean, unbalanced is the best. Right. So for throttling application, where TSO is your primary requirement, unbalanced trim is preferred. That is the point. You got it, friends? Yes. So for a balanced trim, okay, a circumferential seal packing is required between the plugged gauge and the standard material selection for balanced trim seal is this one. PTFE for application up to 200 degree. Friends, are you following? For a balanced trim, okay? This one, okay? Circumferential, the circumferential seal packing here, right? So this is required between the plug, this is the plug, right? Plug and the gauge, right? And the standard material for this balanced trim seal is, this is the one. PTFE application up to 200 degree, okay? For flexible, so for a steam application up to 400 degree, we use flexible graphite seal. Okay. If it is 200 degree, PTFE. If it is 400 degree steam application, use graphite seal. Okay. Then you have a high temperature. For that you use metallic piston ring seal. Okay. These are the some of the facts. And one more point as add-on, asbestos usage or content for sealing, like a gasket, packing, we should strictly prohibit it, forbidden. Okay, friends? Right. So I hope this one is clear, right? Balanced, unbalanced, all these, right? Okay, good. So now a few more. Construction design requirement for rotary valve eccentric plug or segmented. So this is the eccentric plug, friends. This is the eccentric plug, and this is your what you call the segmented ball. Okay, you can see your ball, right? So seat ring shall be fixed to prevent loosening by vibration. Okay, but we should not use adhesive compounds. Okay, seat ring should be fixed, shall be fixed to prevent loosening by vibration, and no internal component shall be welded into the valve bodies or bonnets. Okay, and for control valve with welded ends, the entire trim assembly, including the sheet, shall be removable from the top. From the top, we should be able to remove. This is for rotary valve, eccentric plug, or segmented valve, and the linear motion trim. Okay, friends, these are the things we should make note when we ask for the vendor. Okay, all these. For a trim which are not of one piece plug and stem type, for the trim which are not of one piece of plug and stem type. Normally, how this is a stem and plug, right? So it comes in a one piece, right? So if it is not so, then the plug and stem construction shall be provided with a locking device to prevent the accidental separation of which may result in the stem blowout. So that is the additional point. Stem protector shall be considered for linear motion, whereas if the surrounding atmosphere causes the stem to fall. So these are the additional aspects we should focus when we buy or design a rotary valve or eccentric plug or segmented valve. Okay. Okay, friends, this is clear, right? Okay, good. Now, few more actually. Control valve trim consisting of a plug, seat ring, and stem shall be corrosion resistant. This we all know. But the point is, for application where fluids become corrosive, okay, when in contact with atmosphere, suitable valve stem material shall be considered. Right, friends? Isn't it? Right? Okay. So what we have to do? Hardened stellite or coal monoi coated. Okay. So this is a stellite is a hardened type of term, and here uh, want to inform you what is this coal monoi. See, basically it's a alloy coating material. Okay. So yeah, this is actually developed to provide extended service life at elevated temperature. Especially to the parts exposed to abrasion, erosion, corrosion, all these kind of things. That's the point actually. Okay. So the point is hardened or stellite, solid stellite closure member seat ring shall be selected for what? Erosive services, flashing, and choked flow. Okay. So again, you have any question on this? What is flashing? What is choke flow? All this? Okay. You want to have, in fact, I already, updated in detail. If you want, I can, yeah. See, again, I just want to, as a recap. Flashing is a condition, okay, friends, that occurs with liquid flow. Always remember, when the pressure falls below the vapor pressure. This all remember, this is all interview question actually. Flashing is a condition that occurs with liquid flow when the pressure falls below the vapor pressure and it remains below it. That's a point. Here, two phases of flowing actually. One is the liquid, other vapor. Okay, right. So severe damage can occur inside the valve due to erosion caused by the impact of the liquid droplets traveling at high speed. Okay, so that is the flashing scenario. It's a condition that occurs with the liquid flow where the pressure falls below the vapor pressure and remains below it. That is the point. Okay, friends. And what is the choked flow? See, basically, choke flow is otherwise known as critical flow, friends. Okay, it takes place in a valve when an increase in pressure drop, increase in pressure drop across the valve no longer has any effect on the flow rate through the valve. Okay, when it occurs actually, it occurs when the velocity of the gas or vapor, okay, reaches sonic. What is sonic? That is Mach number 1 at the vena contracta. That is the point. Again, I repeat, choke flow takes place in a valve when an increase in the pressure drop across the valve no longer has any effect on the flow rate through the valve. So that is the definition of choke flow. Okay. So that is the point. And any more you want to have on this choke flow, friends? Or good to go? Okay. So that is the thing. And okay, you may ask like how it occurs actually. Okay. especially in liquid application, choking happens as a result of a pressure reduction through the control element. That's what the definition says, right? Yes. So, so the inlet and the outlet cross-sectional area of the valve are much larger than the control area. Okay. What happened here, friends? As the fluid passes through the restriction, the vena contracta, right? The velocity increases. Okay. What for? To maintain the same flow rate. Okay. So that is the point here. What is the consequence of this actually? The flow, choke flow conditions, it can be damaging, it may damage the valve internals, and also operator might be exposed to noise levels exceeding the safety limit, all these actually. So when we do the sizing, we should consider all these aspects. Mm. And how we can mitigate this? There are few aspects actually. We have to size, as I told earlier, we have to size this control valve, taking into all this choke flow consideration. Of course, we have to consult our, process team. And additionally, we can consider anti-cavitation and noise reducing trim actually. Okay. So these are the things, friends. Okay. Again, coming back to the subject, then cavitation. Okay. So again, this cavitation, right? Cavitation is nothing but a condition that occurs in a liquid flow where the internal pressure of the fluid at some point falls below the vapor pressure. Okay. And the vapor bubbles form, right? At and see the internal pressure of the liquid at some point falls below the vapor pressure and the vapor bubbles form, right? At some other point downstream, it rises above the vapor pressure again. So that is the point. So as this pressure recovers, so the bubbles, it collapses. So the cavitation takes place. Okay. So that is the point. Okay. This is the definition. And where we can use this wet gas or steam service with a pressure drop greater than 5 bar. Now we are talking about the hardened or cellulite closure member where we can use. Okay. So erosive services, flashing, choke flow, cavitation, wet gas or steam service with pressure drop greater than 5 bar. Okay. And also the other services in which pressure drop is greater than 20 bar at temperature above 300 degrees C. That is also, we have to go for this consideration, hardened or sterile. Okay. Yeah. So for economic reason, if you don't have much cost, and if suitable for specified process condition, hardened alloy 6, sterilized 400 series like ASI 410 or ASI 400C. This all actually stainless steel type hardness actually. This is a stainless steel type. So for economic reason and if suitable for a specified process condition, hardened alloy 6 sterilized 400 series like ASI 410 or ASI 400C type stainless steel, hardness approximate of 550 BHN. Again, you may ask, what is this BHN? See, basically, it's a Brinell hardness number. What is it? It's a measure of material hardness, particularly the metals and alloys. Okay, friends. So, Brinell hardness number. So, 550 Brinell hardness number or higher application may be considered as a trim material. That is the point. If you have a cost constraint and if suitable for the specific process condition, we can use hardened alloy 6 sterilized 400 series like AISI 410 or AISI 400C. Okay, that is the point, friends. Okay, then the fluid is of dual phase, gas and liquid, and of a high velocity and high pressure differential across the valve. All this scenario we have to go for this hardened. Never forget this. Okay, right. And also the high temperature application and also application where there is a presence of abrasive solids. That's it, friends. So these are the consideration we have to look out for when choosing the trim. I hope it is very clear, right? I think you are a master now. Okay, good. So now, friends, for the trim selected, trim material selection, material shall indicate a reference to the applicable design codes. What are those? We have ISO, we have a API 600 table 3, and we have a API 602 table 9, and also the BS, British Standard 5353. Okay. For choke valves and valves in other extremely erosive surfaces, special materials such as tungsten carbide and ceramics may be used. But for boiler feedwater application, with the presence of hydrazine that is used to treat water, treat boiler feedwater, tungsten shall not be used. So this may be some reactions, okay? So that should be avoided. And this is the look and feel of this API table 600, friends. API 600 table 3. See, you have this trim number, you have this nominal trim, and you have the seat surface detail, and what is the material surface, what is the typical grade, all these are there. I just put this as a reference. We should actually ask for, that is my point. When the vendor proposes, okay, so better to ask for this, table, so that you can, verify whether you are chosen a correct term. Okay, friends. So that's it. I hope you had a very good insight on the, what do you call the valve, trim, and the types of trim like gauge type, and also the the balanced, unbalanced, and also the what do you call trim material selection for what do you call for erosive service, cavitation service, all these stringent services. Okay. So if you like this video, you can show your support by pressing the thumbs up button, and if possible, become a friends, become a become a your subscribe Be Spice, and if possible, become a member, friends. Okay. Of course, these are all actually, if you want to support me, you do it, no issues. Otherwise, also no worries. You can continue to watch even without subscribing also. Okay, friends. Thanks a lot, and see you in another interesting video. Okay. Thanks a lot. Bye bye. Take care.